In today's lesson, we are going to learn how to write parallel and perpendicular equations. First, let's start off by kind of defining what parallel equations are. Parallel equations are going to have the exact same slopes. What they look like for parallel lines is going to be two lines that are perfectly next to each other that are never ever going to meet. So that's what our symbol looks like for parallel, two lines next to each other that would never meet. For perpendicular equations, they are going to have both opposite and reciprocal slopes. When I talk about opposite, I'm going to mean that we are going to change the sign. So given the slope, we will change signs on it. By reciprocal, I mean that we are going to go ahead and flip the fraction. That's what reciprocal truly means. The symbol for perpendicular is going to be an upside down T. That's what our two lines are going to look like, meeting perfectly at a 90-degree angle. Let's go ahead and practice given a slope, making it parallel. If the slope given is 2, the parallel slope is 2. If the given slope is -1/4, the parallel slope is -1/4. And you could put that negative either to the 1 or to the 4. Choose one, not both. Slope of -3, the parallel slope is going to be -3. And then if your slope is 7/5, your parallel slope is 7/5. That's really nice, but let's go ahead and talk about perpendicular. If my slope is 2, I want to make that slope have a perpendicular slope. The first thing I do is I change the sign. It was a positive, so now it's going to be a negative. I flip the fraction. If there's no fraction, you put your whole number always over 1, and then you would flip that to 1/2. Again, the negative can go to anything. I put it to the numerator. If I have a slope of -1/4, to make it perpendicular, I got to change it to a positive, change sign, and flip the fraction. Instead of 1/4, it's 4/1. We can simplify that down to just a positive 4 overall as its simplified answer. If I have a slope of -3, to make it perpendicular, I change the sign on it, negative to positive, and then I go ahead and flip that fraction. Well, remember, if it's a whole number, you can always put it over 1 to flip that fraction to a positive 1/3. So again, always remember that we change our sign here. If it was negative, we change it to positive, and if it was positive, we change it to negative, and then we go ahead and flip our fractions, just like we've been doing. Last one here, we'll do the same thing. The slope is 7/5. It is a positive 7/5, so I must change that to a negative. Then, instead of 7/5, I flip that fraction to be a 5/7. -5/7 is my perpendicular slope to the given slope of 7/5. Change the sign and flip the fraction. Now let's actually get to writing these parallel and perpendicular equations. For our steps for solving, we have step number 1. With the given equation, make sure the y is by itself before you move on to step number 2. Highlight that y, that is so important. We'll kind of highlight it in each problem to see if it's alone or not. For step number 2, we see if the question's asking for a parallel line. If so, we keep the same slope. If the question's asking for a perpendicular line, we have to change the sign and flip to adjust the slope. For step number 3, we plug in the correct slope m from step number 2 and the given point as x and y to solve for b. It's so important that we never use the y-intercept from the given equation.
In example number 3, I have writing the equation of a line in slope-intercept form that passes through the point -2. We'll label that as x1, comma 7. We'll label that as y1. And we have it being parallel to the line of y equals negative 4x plus 1. So when I see it's parallel, I need the same slope as the given line. So I'm going to pull the slope from the given line, which is my m value in front of x. That's going to be a negative 4. To make that slope parallel, I just keep it the same value. Perpendicular we'll look at later. Now that I have my slope m value, I'm going to go ahead and plug in everything I know into point slope form. Y minus y1 equals m parentheses x minus x1. Well, I keep the y in the problem, and I subtract y1, which is the 7 I mentioned before. I equal it to the parallel slope. That's going to be my negative 4. And I start by parentheses of keeping x, but subtracting my x1, which is a negative 2. Let's go ahead and make that double negative next to each other into a positive. That way I can solve this down. I distribute the negative 4 because I need it in slope-intercept format. Keep the y minus 7 on the left, and I get negative 4x minus 8 on the right. I add 7 to each side. That way my y is all by itself, and my parallel line will be y equals negative 4x minus 1. That answers the question of the line in slope-intercept form that passes through the given point and is parallel to the line we were started with. We're going to write the equation of the line in slope-intercept form that passes through. Again, let's label it x1, 3, and y1, my negative 1. And is parallel, so pulling the same slope from the given line of x minus 3y equaling 9. Now, the issue here is I can't just pull the slope from this form. So since I don't know the given slope, I don't know how to make it parallel. How I find the given slope is by drawing my line and converting this into slope-intercept format. What that means is I get y by itself by first subtracting x from each side, cancels out on the left to a negative 3y, and remember on the right side, I sneak in that negative x in front of the 9. Then I divide every single term by what's next to y, which is a negative 3. When I divide it from the y, that just cancels out to y. Here, two negatives make a positive, and when I have 1 over 3 that's next to x, because the 3 is in the denominator, and technically a hidden ninja 1 would be up here in the numerator. And then I actually divide 9 by negative 3, which is negative 3. Now again, I only want to pull the slope, which will be 1/3. Because it's parallel, I don't have to do anything with that slope except plug it into my point slope equation. So point slope form is y minus y1 equals m parentheses x minus x1. So I keep the y and the subtraction in my equation, and I replace y1 with a negative 1. Then I bring down the equal sign. I replace my m with the parallel slope, which will just be the same slope from the original line, 1/3. Keep the parentheses x, and I subtract my x1, which is 3. From here, I start converting into slope-intercept form. I go ahead and change the two negatives next to each other into a positive and start distributing 1/3 to each term in my parentheses. 1/3 times x is 1/3 x, and 1/3 of negative 3 is really just a negative 1 here. You could type that in your little blue calculators. Bring down the y plus 1 on the left side. Then I subtract 1 from each side. It cancels out on the left to get y equaling a 1/3 x minus 2. That is my parallel equation that goes through the given point. In example number 5, I want to write the equation of the line in slope-intercept form that passes through, let's label it 4x1 and 3y1. And this time it's going to be perpendicular to the given line of y plus 7 equaling 2 parentheses x minus 4. So again, right away, I go ahead and look at my original equation and see if I can pull the slope. Since this is a point slope form, I can pull the slope from in front of my parentheses. The slope of my given line is 2. But this time, to make it perpendicular, remember I have to do 2 things. That is going to be, I'm going to do the opposite sign, so it will be a negative instead of a positive. Then I have to flip it. Now, to flip it, I have to put 2 over 1, so that way I can write it as 1 over 2, that's negative. And that's my perpendicular slope. I'm going to plug into my point slope form, y minus y1 equaling m parentheses x minus x1. I keep the y and I subtract my y1, which we labeled as 3 for this problem. The slope now is a negative 1/2, like I wrote above, making it perpendicular, in front of the parentheses of x subtracted by x1, which is 4. I'm going to go ahead now and get this in slope-intercept form. I start by distributing the negative 1/2 to each term in my parentheses. Negative 1/2 times x is just that, negative 1/2 x. Negative 1/2 times negative 4, I'll put the 4 over 1. That way I multiply straight across the top here. Negative 1 times negative 4, that is 4 here, a positive 4. And then I'm going to go ahead and divide it by multiplying my denominator terms of 2 times 1, which is 2. From here, I just simplify that fraction, which is going to go ahead and be 4 divided by 2, that's 2. I bring down everything else in the problem before I get y by itself. It's a negative 3 next to y, so I'm going to add 3, and I get my final answer of the perpendicular line through the point, that the answer is y equals negative 1/2 x plus 5. In example number 6, I want to write the equation of the line in slope-intercept form that passes through, again, let's label it, x1 as negative 5, y1 is 1. It's perpendicular, so we have to make the slope opposite and reciprocal. Slope is going to come from the line of 5x plus 3y equaling negative 21. Now, I'm not able to pull the slope right from the equation in this format, so I must convert to slope-intercept form. What I do first is always subtract over the x term from one side to the other. It cancels out on the left to just a 3y, and I sneak it in front of the negative 21 on the right side. We now divide everything by the number next to y, which will be 3. When I divide 3y by 3, it cancels out to just a y. When I divide negative 5 by 3, it's left as a fraction. And when I divide negative 21 by 3, it comes out to negative 7. So I'm pulling the slope from what's on x here for my original equation, and that's negative 5 over 3. But remember, that's the slope of the initial equation, and I need to make this slope perpendicular. Remember, the 2 things we have to do to make it perpendicular are flip the fraction. So instead of 5 over 3, I'll have 3 over 5. And it was negative, so now I'll make it positive overall. That's the slope I'm plugging into my point slope form, y minus y1 equals m parentheses x minus x1. I keep the y and subtract my y1, which is 1 for this problem. I equal it to the new perpendicular slope of 3 over 5. That's in front of my parentheses of x minus, and I'm subtracting my x1. From here, I go ahead and solve this by distributing the 3/5 to every term in the parentheses. First, let's make that double negative into a positive. And then I have y minus 1 equals 3 over 5x, because 3 over 5 times x is just that. And then remember our trick from the last problem. I'll put the 5 over 1, and I'll multiply the numbers in the numerator. 5 times 3 is 15. And then I'll multiply the numbers in the denominator. 5 times 1 is 5. After I multiplied the fraction together, I simplify it down. 15 divided by 5 is just 3. From here, I am so close to done. I just have to add 1 to get y by itself. And what I do to one side, I do to the other. Cancels out to just y on the left side. And it equals 3 over 5x plus 4. That is the line perpendicular through the given point.
Now we're going to do some examples with Desmos application. How can I tell if the lines are parallel? Remember that they have to have the same exact slope, and we can count rise over run on the graph for both lines. So I want to find 2 nice points of my top line here. These 2 will work great. And then I count how far up, which is just positive 1, and how far over, which is positive 1 since it's 1 to the right. So that slope is going to be 1 over 1, which is simply a slope of 1. We then look at our second line. I'll use a different color here and find 2 nice points there. I'll count how far up, which is plus 1, and how far over, which is plus 1 as well. 1 over 1 gives me the same slope of 1 that my other line had. Another way you can look on Desmos to figure out if they are parallel or not is that the lines will never touch. So if you look on Desmos and you zoom out as far as you can and they never touch, that's going to end up being a parallel line. How can I tell if the lines are perpendicular? They have to have opposite. Remember, that means change the sign here. And reciprocal is a fancy word for flip. But they have to have both for the slopes. We still will count that rise over run again for both lines. Let's go ahead and start with the first line here. We're going to find 2 nice points right here. Count far up, plus 1, and how far over, plus 2. So that slope of that line is going to be up 1 over 2. I'll write it over here. Second line, let's find 2 nice points again. We go ahead and have one at negative 3 on the y-axis, and here, count down 2 to the right 1. That's going to be my slope here. As you see, I flipped those fractions, and I also made the sign change. So that's going to go ahead and be perpendicular. Visually, how you can tell as well, it's going to form 4 right angles. What I mean by right angles is at the intersection here of both my lines, I have perfect 90-degree right angle boxes as the intersection. Let's go ahead and try these in Desmos. So I'm going to put in the given point in Desmos for example number 7. So that point is going to be negative 1, negative 5. That's going to be my green point in Desmos. Step number 2 is I want to put in the given equation. So my given equation is going to be y minus 4 equals 3 parentheses x plus 2. And that's going to go ahead and be my purple line in Desmos. From there, I want to try each answer choice and eliminate any that do not go through the point or that do not have the parallel or perpendicular slope. So right away, I see this example says select the equation of the line that passes through negative 1, negative 5, and is parallel to the line. So I had to have the same slope as the line. Pulling the slope from the line when it's in point slope form, it's always the number in front of your parentheses. So my m or slope must be 3. Well, right away, you can also eliminate some here too because your slope is in front of the x here, and it must be 3. So right away, even before going to Desmos, I can eliminate b and d. But let's also see why in Desmos those don't work. So looking at example b, it was y equals 2x minus 3. It does go through the point, but as you see, when I zoom out, they do end up meeting these 2 lines. And remember, parallel lines can never meet. Trying example D as our answer choice. As you see, it does not even go through the point, and it intersects the line, so it can't be parallel or the line suggested here. So I have A and C as my final options. Putting on both A and C, I can see only one of those goes through it, and that's my blue line of y equals 3x minus 2. So that's going to be C, not A, as my final answer. Next, example 8, select the equation of the line that passes through 2 comma 4. Again, that's going to be my green point and is perpendicular this time to the line 3x minus 6y equals negative 6, and that will be my line in. For this example, I can't easily find the slope, so I'm going to go ahead and rely heavily in Desmos. So let's go ahead and try each answer choice. When I try answer choice A, it does go through the point, so I'm going to go ahead and keep that possibility. Example B does not go through the point, so let's eliminate that one right away. Going ahead and trying example C, let's go ahead again and see if that passes through. It does, good. So I'll keep that for a second, and then we'll look at D as well. So all of those that are left end up passing through the point. Now we just got to figure out which one's perpendicular. Well, let's look back at example C because right away these lines are never going to touch, which means that's a parallel case, not a perpendicular case. So let's get rid of our C, y equals 1/2 x plus 3. I have two options left, and let's toggle them both on in Desmos. Remember that visually perpendicular is going to be the exact opposite slope, and it's also going to make a 90-degree angle with the intersection here. So visually, you can see that this first line, option A, is not going to make a perfect box around your intersection. So therefore, it would be your option D of negative 2x plus 8. If you're still not convinced with the visual, we can go ahead and find the slope of these two lines here. How we count slope is we find two nice points on our graph. So let's go ahead and do that for the green line. One point's already given to us, and another one is perfectly down here. Counting down 1, 2, to the right one's going to make that negative 2 over positive 1 for our slope of the green line. Finding two nice points on our purple line is going to be at the y-intercept of 1 and the x-intercept of negative 2. We again count the rise, which will be plus 1 this time, over the run, which is positive 2. That slope is going to be 1 over 2. And as you see, between the two slopes, I did indeed flip it from 1/2 to 2 over 1 and switch the sign from positive to negative.